Okay, so we've now discovered that pi, which is written like this, it's a Greek symbol, pi, is around 3.14. And you found that out by doing your calculations of circumference divided by diameter. Do you remember? C over D. Okay? So if we've got a circle here with a radius of 5 centimeters, we can work out its circumference using pi. Okay, so if the radius r is 5, then the diameter, remember the diameter is double the radius, so the diameter is 10 centimeters. So from this expression here, we can work out that the circumference is pi times d. So it's the diameter times 3.14. So in this case, the circumference would be pi, which is 3.14, times the diameter, which we worked out as 10. And so the circumference of this circle would be 31.4 centimeters. Now for the area of circles, we can also use pi. So pi is still 3.14. The reason pi is always the same number, that is, we're looking, remember, at the relationship between the radius and the diameter of a circle and its circumference, so all the way around. The reason it's always the same is that a circle always looks the same. Even a little hand-drawn circle, they all, whatever the size, they all are the same. Therefore, the relationship between the diameter and the circumference are always the same. Now, the area of a circle. Now, for the area of a circle, I've drawn a rectangle here because normally we would talk about the length of the rectangle and the width of the rectangle, and the area is just the width repeated however many times the length. So we know that the area of the rectangle is length times width, and it's essentially this width repeated across the length of the rectangle. I hope you see that. So it's just width times length, and eventually the whole space is filled up. And the let's just say this is going to be 20. Remember the units, they're squared centimeters. The area of a circle has a special formula, and the formula relies on the radius. So if we take our radius here, 5 centimeters again, and use the formula. The formula, it looks complicated, but the formula is written like this: pi r squared, and that will give us the area of the circle. And all that's saying is take r, the radius, square it, and multiply by pi 3.14. So in this case, it will be 5 squared times pi, which will be, I'm going up here, which will be 25 times 3.14, which is equal to 78.5, and the units are squared centimeters again, because we have taken the whole part of the circle and calculated its area. So we can do some quite interesting things with this. For example, if we're asked for the perimeter of this shape, imagine you are here and we want to trace all the way around the perimeter of this shape, which includes those two straight lines. So I think we are told, let's assume, that this is a right angle here. So we have a radius of 5 centimeters. If we know the radius is 5 centimeters, then the diameter is 10, because it's just double the radius. From that, we can work out the circumference using pi d. So we know that is 31.4 So 3.14 times 10, 31.4 centimetres. Now, we've only got 3/4 of that because we're starting here from the circle. We've lost a bit. Okay, so this bit here we're not worried about. So we've got to multiply that by 3/4 or find 3/4 of it. Okay, you can divide by 4 and multiply by 3 if that's how you like to do it. So we're going to go 31.4 times 3/4, and that will be 23.55. Right, and that, because we've got 3/4 of the circumference, that will be that distance. But we've still got 2 of these. To find the perimeter of this Pac-Man shape, we've still got 2 of these. There's a 5 and a 5. So we've got to add on 23.55 plus 5 plus 5, and that will make the perimeter of this shape. So running from, say, start here, running from there, down there, around there, and back here, the perimeter, let's call it P, is 33.55 centimetres.